Hey guys, today's video is on the probability of compound events. There are two different types of compound events. The first one we have is independent events. With independent events, the outcome of one event does not affect the outcome of the second event. They're independent of each other. A formula that we can use to find the probability of A and B, two independent events, is taking the probability of event A and multiplying it by the probability of event B. So if they're independent events, obviously you should think, well, the opposite of that would be dependent events. Dependent events is when the outcome of one event does affect the outcome of the second event. Again, we find the probability of these two events by taking the probability of event A and multiplying it by the probability of event B. But event B's probability is going to depend on what happened during that first event. All right, so let's look at some examples. Our first example says that a box contains 3 red marbles, 4 green marbles, and 5 blue marbles. One marble is taken from the box, and then replaced. Another marble is taken from the box. What is the probability that the first marble is red and the second marble is blue? Well, one of the key things that we need to look at here, it says one marble is taken from the box and then replaced. Okay? So if I take a marble from the box and I put it back in, does it affect what happens when I go ahead and take my second marble out? No, it doesn't. So a note to yourself is that these are two independent events. Alright, so all we need to do is find the probability of pulling a red marble and multiply it by the probability of pulling a blue marble. Well, if you remember from simple events, we just need to find our number of favorable and put that over our number of possible. So I've got 3 red marbles out of a total of 12 possible marbles. So my probability of drawing a red marble is 3 out of 12. My probability of getting a blue marble is there are 5 blue marbles out of 12 possible marbles. And so all I have to do to find my probability is multiply these two. Remember, when you're multiplying fractions, you just multiply straight across. So 3 times 5 is 15. 12 times 12 is 144. And I know that that can be simplified by dividing both of those by 3. And so I get my probability of getting a red and a blue is 5 out of 48. All right, let's try a second example. Suppose you have a coin and a standard die. What is the probability of tossing the coin and getting heads, and then rolling the die and getting a 5? Alright, well, when you have a coin, your coin has 2 sides, right? It's got a head side and a tail side. So when I look at the probability of getting heads, well, there's only 1 heads out of 2 possible sides. So my probability of flipping heads would be 1 out of 2. Sometimes you'll also hear that referred to as a fair coin. When I'm looking at a standard die, my standard die has 6 different sides. Okay? Well, there's only one side that has 5. So that's 1 out of 6 possible outcomes. So my probability of getting a 5 is 1 out of 6. And all I have to do to get my probability of getting both events would be to multiply 1/2 times 1/6 to get a probability of 1/12. And let's make sure we think about this. Does what I flip on my coin affect what happens with my die? No, it doesn't. So that I know that these are two independent events. All right. So what I want you to do now is go ahead and pause the video while you work example number 3. Alright, so what's key in this problem is that the first card is shuffled back into the deck. So if I take a card out and then I put it back in, I still have 52 cards. And so what happens on the first event has nothing to do with the second event. So you should have identified this as independent events. Now for those of you who aren't familiar with the deck of cards, I've got a picture here. There's 4 suits, so you've got your clubs, diamonds, hearts, and spades, okay? And each one of those has those 3 face cards, Jack, Queen, and King. So there are a total of 12 face cards. So my probability of getting a face card is 12 face cards out of 52 possible cards. Okay? And so you can multiply straight across, or you can simplify these before you multiply. I know both of these I can divide out of 4, and so that's 3/13 times 3/13. And I get 9 out of 169 is my probability of getting a face card and then another face card if it's shuffled back into the deck. Alright, let's go ahead and look at another example. Alright, so our next example, a box of donuts contains 4 glazed, 3 cream filled, and 2 jelly donuts. What's the probability of reaching in the box without looking and getting a cream filled and a jelly donut? Okay. Well, I'm not the best artist, but I got my donuts drawn over here. 4 glazed, 3 cream, 2 jelly. Okay. And I'm going to look at first the probability of getting my cream filled donut. Well, I have 3 cream filled donuts out of a total of 4, 5, 6, 7, 8, 9 donuts. Okay. So that's my probability of getting my cream filled donut. But I want a cream filled donut and a jelly donut. So one of these cream-filled donuts is gone if I got that one on the first draw. Okay? And so then when I go to find my jelly donut, well, there's 2 jelly donuts, but are there still 9 donuts total? No, one of them is gone, so now I've only got 8 possible donuts that I could be picking from on that second time. Okay? And so since what happened the first draw affects what happens my second time, I know that these are 2 dependent events because what happens on the first time affects the outcome of my second event. But I still find my probability by multiplying straight across. Okay, and so I know 3 times 2 is 6, 9 times 8 is 72, and I can simplify those by dividing by 6. Okay, and I get that my probability of getting a cream filled and a jelly filled donut would be 1 out of 12. Okay. Alright, in our next example, a box contains 5 pennies, 2 nickels, 4 dimes, and 5 quarters. Find the probability of choosing first a dime and then without replacing the dime, choosing another dime. Okay, and so let's first look at the probability of getting that first dime. So I've got 4 dimes out of 16 total coins. Okay. Well, if I actually got that dime on the first chance, when I go to get my probability of my second dime, now there's only 3 dimes left. And are there 16 coins anymore? No, because this one's gone, so now there's only 15 coins left. Okay? And so again, you should have identified this as dependent events because what happens in the first event affects what happens in my second event. But I still get the probability by multiplying straight across. So 4 times 3 is 12, and 16 times 15 is 240. And I can simplify that by dividing both of those by 12 to get a probability of 120, meaning I have a 1 in 20 chance of picking 2 dimes from the box. Alright, go ahead and pause the video while you work the last example. So when you see that the first marble is not replaced, that should tell you that these are 2 dependent events. Okay, and so if I get that green, that's a 5 out of 15 chance. Now that that green one's gone, there's only 14 marbles left, 2 of those being pink. And so I multiply straight across, 10 over 210, and that simplifies to 1 over 21. So you have a 1 out of 21 chance of getting a green and a pink marble. Alright guys, so that's all we've got. Make sure that if you need to, you go back, rewind, take this at your own pace so that you can come to class ready to work on compound events tomorrow. Also, don't forget your summary that is supposed to be at least 2 complete sentences, and you should be answering the question, how does the probability of dependent events differ from independent events?